set notation, conditional probability. We have three sets, A, B, and C, and we have an overall sample space given. To draw a Venn diagram, we can start by drawing a rectangle, and inside it we will draw in the circles or ovals representing the sets given. Looking at the first element of A, we can see that 2 is included in all of these three sets given, A, B, and C. So we will write our 2 in the middle where the overlap of the three circles are. The number 3 only shows up in the sets A and B. We will place it in the overlap of A and B, but not in C. Number 5 only shows up in A, so we will place it accordingly, and so on, until we fill in all the values of the Venn diagram. Find the following sets, A union B. These are 1, 2, 3, 4, and 5, as shown in the shaded diagram. A union B union C, A union B are the elements above, and we also have to add an extra element, which is 6, part of the C. A intersection B intersection C is the overlap of the three circles, and this is 2. A union B union C not happening, or in other words, the complement of A union B union C is going to be equal to 7, as you can see it shaded in yellow. The complement A shaded in pink, complement B shaded in blue, and the complement of C shaded in yellow, so the element of this overlap color is 7, which is identical to the above, which takes us to this formula. The complement of a union is equal to the complement of A intersection complement of B intersection complement of C. From here follows another formula, A intersection B intersection C not happening is equal to A not happening union B not happening union C not happening. Looking at the sixth question, A shaded in yellow, intersection with the complement of B union C, which is shaded in blue, their intersection shows us that the answer is 5. In the last question, applying the formula that we have deducted earlier, we can see that the complement of B union C is equal to the B not happening intersection C not happening. So the previous question and this question is asking us the same thing. The solution then is equal to 5. A card is selected at random from a pack of 52 playing cards. Let A be the event that the card is an ace, and D the event that the card is a diamond. To start answering these probability questions, we first draw a Venn diagram. Drawing a Venn diagram is gonna make our life much easier. There are 4 aces in a pack of 52 playing cards and 13 diamonds, represented in blue. And there is one overlap. There is one card only, which is both an ace and a diamond. That is the ace of diamonds. And there are 36 left over, which are not aces and not diamonds. The probability of A intersection D, the probability of A and D, or in other words, what is the probability that when we draw a card from this pack of cards, the card will be an ace of diamond? This is 1 out of 52. The probability of A or D, or in other words, what is the probability that the card that we are drawing is either an ace, either a diamond? The shaded area represents what we need. There are 16 cards out of the 52 playing cards that we are interested in, so the probability will be 16 out of 52. What is the probability of the complement of A? Or in other words, what is the probability that we are not going to pick an ace? As the shaded area shows, the probability will be 48 out of 52. We can also calculate the probability of a complement as 1 minus the probability of A happening, and that is 1 minus 4 over 52, which gives us the same answer, 48 out of 52, as expected. The probability of A not happening intersection with D, as we can see from the shaded Venn diagram, the probability is going to be 12 out of 52. Given that the probability of A is 0.3, probability of B is 0.4, and their intersection is 0.25, explain why events A and B are not independent. Whenever we have a question about independent probabilities, we always start by writing out the formula. If event A and B are independent, probability of A times probability of B is equal to their intersection. Starting with the left-hand side, probability of A times probability of B is equal to 0.3 times 0.4 equals 0.12. Comparing this with the right-hand side, probability of A intersection B is 0.25. And we can see that the left-hand side is not equal to right-hand side, therefore the events A and B are not independent. Given also that probability of C is equal to 0.2, that events A and C are mutually exclusive and the events B and C are independent, draw a Venn diagram to illustrate the events A, B, and C, showing the probabilities for each region. We can start by A and C are mutually exclusive. So in a Venn diagram, it means that they will not have any overlap. B and C are independent, so their product will be equal to their intersection. 0.4 times 0.2 is equal to 0.08. The probability of C is 0.2. Subtracting the overlap will give us 0.12. So now we have two areas completed in the Venn diagram. We also know the intersection of A and B is 0.25. Subtracting this from the probability of A, which was 0.3, we will have 0.05. So now we have four areas filled in the Venn diagram. And knowing that the probability of B is 0.4, subtracting the two overlaps that the B has with A and C, we will have 0.07. And finally, we need the complement of the union of A, B, and C, and that is 0.43. For part C, we need to find the probability of A intersection B not happening, union C. We will start with the inner bracket, S shaded in yellow, C shaded in blue. We can see that their union is their sum. There is no overlap for us to subtract. So the answer is 0.05 plus 0.2 equals 0.25.